Alright, so today we're going to be going over counting problems. And the premise is pretty simple. Basically, counting problems will ask you to count how many shapes are in a certain shape, or a certain bigger shape. So let's do some example problems. How many triangles are there in each of the following figures? So here we have a triangle with two lines in the middle. And we can count some triangles pretty easily. We have 3 small triangles, and we have 1 big triangle, like going around the border, but we also have 2 smaller triangles. Now there's 1 smaller triangle here, and there's another one right here. So all in all, that is 6 triangles in total. Now, similarly on the left side, we have 4 small triangles. We have these triangles here, this guy, this one, and also this one. So that's 3. And we also have the bigger ones with three triangles inside of them, and that's 2 of them. And finally we have the large one on the outside, and that's 1. So this gives us 10. So if it's about triangles and it looks like this, it shouldn't be too hard. Just find and count every triangle that you can see. On the other side, counting squares like this might be a little more tricky. So how many squares are in the following figures? So an easy way we can do this is by counting systematically. So for squares, there are 2 types of squares in these images. One, there's a square that just has 1 little unit square. But there's also a 2 by 2 square. So for example, this right here is still a square, but it has 2 by 2 unit squares inside of it. So what we do is we count the small squares first. So 1, 2, 3, 4, 5, 6 small squares. And next we can count the larger squares. So for the 2 by 2 squares, we have 1 here and 1 here. So we have 2 sets of those. So we do 6 plus 2 equals 8, and that is our final answer. And we can use the same strategy here. We can count the little squares and the big squares. For the little squares, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 little squares. And for the 2 by 2 squares, we have 1, 2. 9 plus 2 is 11. Alright, here we have something a little more complicated. We're asked to count the number of triangles in each of the following figures. We can sort of use the same approach here. First, let's count the number of triangles that, the small triangles. So we have 1, 2, and 3. So we have 3 small triangles, and there are also triangles with 2 shapes inside of them. For example, these ones. We have 1, 2, so we have 2. But we also have some more. We also have this one and this one. So we have actually 2 more, so 4 in total. And finally, we have the larger general triangle, so 1 more. And in this case, we have 5 plus 3 is 8, so we have 8 triangles in total. Alright, so let's go ahead to 4a, and this will be our last problem. So it's asking us to count the number of rectangles in parts A and B, so we'll do A. So similar to the square problem before, we can count the number of rectangles systematically. So there are 3 types of rectangles. This is one, this is another one, and we also have 2 on its side like this, And we also have the pair of 4. We'll just ignore B for now. But in part A, we have these 4 types of rectangles we can make. So let's count the number of small rectangles first. We have 1, 2, 3, 4. So that's 4. Now we can count the number of rectangles that are stacked like this. And I see 2. 1 here and 1 here. So we have 2 here. And for the number of rectangles that are side to side, we also have 2. 1 here and 1 here. So we can write 2 here. Oops. And for a large rectangle, we have only 1, and it's the whole picture. So we have 1 here. And what we do is we add 4 plus 2 plus 2 plus 1. That gives us 9, and that is our final answer.